photoelectric effect. So when photon, when lights, so lights here, we mean photons. So photons in Chinese is 光子. 光 means light. 子 means kids. 光子 means photon. Photoelectric effect in Chinese is 光电效应. So 光 means photo. 电 means electron. And 效应 means effect. Okay, so our apparatus looks like the following. Sorry. So we'll shine lights on this metal surface here. This is our photon. So as we shine on it, we're going to change the color here. The electron, the free electron that inside this surface here, you have atoms and you have free electron. So this free electron can come out. So then they will arrive at the positive terminal here, and then it will close the loop. So since this is electron going that way, it means the current is going this way, so this must be positive, and that's negative. And we'll put an ammeter here, ammeter here to measure current. So this is ammeter. So 安培计, it's called 安培计, to measure current. So the current is going this way, but electron is going the opposite way. So electron is going this way. So we're going to define, so this is V in general. But if we increase this V, so this is positive and negative, so this electron will come out with kinetic energy. And plus that you have positive here to attract it. So then it will for sure arrive at this terminal and go through this and create a current going this way, right? Electron flow going that way. Now, if we make this one a variable voltage source, meaning that we can reverse the polarity, and we also can change the V value. So if we make this one here, now instead of going this way, we reverse it so that this becomes minus and positive. So instead of that, now we have this now. So this will be this going this way, and this one will be minus. So then electron actually would have to overcome this voltage or potential difference to arrive at here. So once you increase this to a V, we call that stopping voltage. So stopping voltage, V0, right, to reach a critical value. And this V0 will be equal to the kinetic energy maximum that this electron has. This electron that got ejected. So this is ejected, right? So this is ejected electron. So that is one thing that this is called stopping voltage, and that would be just equal to the maximum. So when it has the kinetic energy and it overcoming the electric potential, when it arrives here, it becomes zero. So basically you will have zero kinetic energy here, right? When you arrive here, it will become zero. But you just arrive, okay? So that's the critical case that this V0 that has negative on this side, positive on that side, and it will have, you know, at least one electron that has the maximum kinetic energy will arrive here, and it still close the loop. So after that, the ammeter should measure 0. So according to Planck's and Einstein, the energy of an electron is equal to a Planck's constant times the frequency of the vibration. And so this is the energy of a photon. And H is so-called a Planck's constant. And this is the frequency of the vibration. And it's also the frequency of the light, of the photon. So H is equal to 6.63 times 10 to the negative 34 joule second. Okay, that's the unit. And energy here is still in joule, and this is in hertz. So that will be 1/second. So you can see it cancel this second and become joule. Now, this energy that we have, so HF, right? So this photon that we have, so remember we have photon shining at our plates here, our metal plates, right? In our previous discussion here. So this is photon. So this photon has energy equal to H times F, right? So it's just one photon. So photon has no mass, but has momentum, has energy. So when it arrives here, this energy will be divided to two things. One is called work function, and one is the kinetic energy that will come out. So how does that work? So when this W is called work function, and that's needed to overcome the energy needed. This is the energy needed to eject, right? Eject free electron, right? Free electron. Well, it's not eject, okay? To eject free electron to the surface, right? To the surface of the metal. Of this metal here, right? And when it comes out to here, this work function will eject this electron, right? With basically with velocity equal to 0. Okay? So this work function will bring, okay, maybe the better word is to bring, okay, electron to the surface of this metal here, right? So inside here we have atom, remember? And then we have free electron that's moving. And this electron will come out up to the surface here, right? But it's only have velocity equal to 0. But if you have more than that energy, so HF has more than the energy for the W, then it has additional energy to let this electron have some velocity, right? So this electron, when it comes out, it has some velocity, okay? So then this velocity does give the electron the kinetic energy, and this energy will be equal to 1/2 m of the mass of electron, which is 9.11 times 10 to the negative 31 kilogram, according to the electron experiment, and times the V that this guy has when it got ejected by the photon with the energy of HF. And the photon has frequency of F, hertz, right? And with that constant, this constant here, so then this is what you have. So basically you will have, so this is your KE, and this is your work function, and depends on your F. So the higher the F, the higher the energy. So then this energy will be, you know, so if you just give it the F right there, for example, right? Give it F right there. So sorry, this should be F0, right? If you give it F0 right there, then it will have basically the work function just enough just for the work function. If you only have F0, so then your energy will be basically equal to HF, which is equal to W, and then plus 0. So that point is right there. You have kinetic energy equal to 0, right? Kinetic energy equal to 0. So this HF is just enough to overcome it, so it will come out to the surface with velocity equal to 0. And that is the frequency of the photon that you have. As you increase this F of the photon, then you will see this kinetic energy of the ejected photon will also increase linearly. Okay, so that's all for the day. And what we're talking about is photoelectron. Let me clear it and just give a summary. So we talk about the photoelectric effect. Okay, and so that's using the photon, and this can eject electrons, right? And the speed of electron can vary. The second thing we introduce is the energy function for the photon, which is HF, and that's the Planck's constant, so Max Planck, and that's 6.63 times 10 to the negative 34, which is quite remarkable. You can actually calculate the energy of a photon based on the frequency, right? And that's in hertz. And then we introduce the W, which is the work function, right? And that's the energy that's needed to bring the electron to the surface of the metal, right? So this is the energy. This is the energy, right? So in joule, okay? And then we introduce the relationship between HF. This HF of the photon can be used to do two things. One is to provide this energy to bring the electron out, and the other one is to give the rest of the energy to the electron so that it has kinetic energy to travel to the terminal. All right, that's all we have. Thank you for watching, and we'll see you next time and for more physics.